Okay, this is something. Now we are going to see in detail that what exactly we have learned for photoelectric effect. Now I just want you to observe certain things from here. Okay. So this is how it looked like. Photoelectric effect tube, the opening, and now look here. This is what the experiment is. First, focus on certain things. Okay. Let me just align this first. Yeah, now everything is visible to you. See, you can see my cursor. This is the part where it is wavelength. This is the part where it is frequency. Down it is intensity, which is written as photon density, and then you have a voltage. Okay, I'm going to just decrease the value of frequency first. Okay, and you can see that if I go for a certain radiation, you can see there is no emission of electron which is happening. Okay, it's just like, let's say the material has been exposed to some kind of a yellowish light, and that yellowish light is something which you are increasing in terms of bulb. If there is a 1 bulb, and if I say there is 10 bulb, so that is something which you can change by intensity. So when you keep it minimum, let's say it's like 1 bulb. So light is falling from a one particular bulb, but if I make it like 10 bulb, 20 bulb, 50 bulb, 100 bulb, 2000 bulb, even 10,000 bulb, do you think the emission of electron is going to be take place?
No.
No. That is something which you need to understand, that intensity does not have any effect on emission of electron till the time it is below the threshold frequency. Are you getting my point?
Yeah.
And that is something, you know, when examiner says that why photoelectric effect cannot be explained on the basis of wave theory, this is the same point which you can mention over there also.
Okay.
Now if I go to a certain value, let me first decrease the intensity to minimum, and then I'm keep on increasing the value of frequency. I'm going to a green part, slowly steadily, you can see it over here, the value of frequency is increasing, and I will find a point where it is minimum which has been provided to the metal and the electrons are coming out from the surface.
Yeah.
So ultimately this frequency, what are you going to call?
Threshold frequency.
The threshold frequency, the minimum frequency which can emit the electron from the surface of a metal. Next thing which I want you to notice this, or you can comment on it. What do you think what will happen in case if I jump from green to blue? That way I'm saying I'm increasing the frequency. So what do you think according to you is the effect of frequency on this particular emission?
The number of electrons emitted should be more.
It is not the number of electrons emitting will be more. It is something else. If you be precise, notice this and then you tell me what is happening. Like I am going,
Speed of the electron changes.
look at the speed of the electron. So by increasing frequency, what you can say?
Speed of the electron increases.
So basically the kinetic energy of electron is increasing. So remember here, the gap between the electron has been increased. That means in the same intensity, if you go and you're increasing the frequency, the emission of electron might be initially it was happening 10. This time it will happen 5. But the kinetic energy which is possessed by them is going to be higher.
Increased.
Okay, so you're getting this point?
Yeah.
And this is the same way now you relate in case if I increase the intensity from here. Now what do you think if I increase the intensity, what is going to be happen?
Then the number of electrons will increase.
Wonderful, because you can see if I keep on increasing the intensity, the more the intensity you will make, the more the number of electron will be emitted from the surface of the metal, and the more the current is going to be passed through it. Got it? This point is clear?
Yes.
Okay. Now suppose I will again go back to the threshold frequency. So let's find the minimum point where it was happening. Now so I can say that this is basically the minimum frequency where the sodium is giving us some kind of emission of electron. Correct?
Yeah. Yeah.
If I change the metal, like if I change the metal to carbon, so you will notice that carbon, the moment you change the metal, sodium is showing you emission of electron at this particular frequency, but carbon not necessarily having the same threshold frequency. So the threshold frequency is something which can change from metal to metal.
Yeah.
It's just like concert to concert, the price can be different, depend on the artist. The similar way, metal to metal, the threshold frequency can be different. So here might be the threshold frequency which you needed, it is higher. So you can keep on increasing, and at one particular point you will be able to find, okay, this is the place where the emission of electron is happening. So I'm increasing, look here. And this is the same rule. If you go for more frequency, kinetic energy will be higher, or if you change the intensity, the relation is going to be same. Lesser the intensity, emission of electron will be less. More the intensity, the number of emitted electrons are going to be more.
Okay.
All this thing makes sense?
Yeah.
Good. Notice one more thing. I'm going back to the same old material, which is sodium. So here we have the frequency. Okay, this is the threshold frequency. Let's keep it a little higher. Okay. Now question here is, at this particular frequency, can we calculate what exactly is the speed by which these electrons are coming out? For that, what I told you, that you have this plate on this side and you can increase the voltage. Now look here, here is the voltage value. If I increase the value a little, the electrons are still able to reach the other side of the plate. Let's increase a little more.
It will repel when it reaches.
So you can see that the speed is decreasing, but still they are able to reach the other side. Let's increase it a little more. Oh, it reaches here also. So increase little more. Let's increase little more. So slowly, steadily, I will keep on increasing my voltage to see at what point none of the electron reaches to the other side, and that voltage I'm going to call it as my stopping potential.
Okay.
So I think you can see that the minimum potential I require is somewhere around 0.3, and that is the same voltage which I can use to calculate my velocity,
Okay.
which is half mv square is equal to ev, and that way I will be able to calculate my velocity. So this is what we need to understand when it comes to the photoelectric effect experiment: the relation of frequency, the relation of intensity, stopping potential role. And if you're able to comment on all those things, the things are sorted.
Okay.
Got it?
Yeah.
Any question?
No.